Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and this is another video repeat. We'll try it again this time. As I said in the current video, I was using this Arduino board, and there is one little resistor that I needed to add here, 4.7K resistor, to turn off this when I disconnect the power source. It still can stay on sometimes, unless I add that resistor. Anyway, start this video over again. What we're going to do is go from 12 to 20 to 48 volts, and we're going to add a battery to be charged here just to show that. So nothing really new in this video from the last one, which I guess I will delete, but I will show more details. I do have the tachometer here ready to tape up, so I will show that. Not really important, but you can get an idea of the RPM. So it's ready to go 12 volts. We have another battery here that isn't going to be connected yet because we're going to run the lights again, and we'll go through this quickly. Again, this is going to be part of the assembled kit now. A speed control will be included, and the unassembled kit, you can order that as an option shortly. I'll have that on the website, but for all assembled kits from this point, we'll include this in there, and this will be the board that is both the speed control and where the MOSFET is located. So this is an upgrade. It gives you several features, and the other great part will be any kind of additions we add to the programming of this board will be free. So that all you have to do is hook it up to your computer. There will be a connection to your USB, and it'll be a very simple plug and play operation. So you'll be able to see all the parameters that you can adjust, such as the pulse and the width, and then there is a little potentiometer here that we may just leave on the board, we may not, because if you don't have that the right setting, it could be bad at the higher voltages. Anyway, what else is there to say? I said last time, there is a power supply port there if you want to supply 12 volts, I believe there. There's a voltage regulator on board which converts it to the 5 volts to run the gate driver. And there is no opto because we reversed it, so we don't need the little opto, one less part. Pretty simple to solder and put together according to the instructions. And we have to run it though only on 12 volts. So this extra wire here, we've got this battery bank is going to be the input, 12, 24, 36, 48. We'll go through each one. This is the charging side, this is the input battery, this is the charging battery, and we're going to go up the scale here. So last time what I did was I went through this, and then when we went up to 48 volts and I disconnected it, probably when I disconnected it at the 36 volts, it still stayed on under that moment, and that's when it damaged the MOSFET. And then of course we lost it pretty quickly when we went up to 48 volts. So let's look at the whole thing over again. And there's no heatsink on here, and if you go beyond 24 volts, I've said you should probably have a heatsink on there, especially if you load this thing down. But we're not going to load it down really right now, we're just going to run it as So I'm just going to, this one's not self-starting because I have it really, the gap really close. And again, like I said in the last video, these are new rotors. They don't have hubs on them. So I can make the gap on either side pretty narrow. Well, as narrow as I want it. Now this is a little, maybe a little too close that I've found, but I want to get closer for the generator coils so they can put out more. So let's just look at it all and go from there. So right now I don't have it on full blast. To get started, we will have that, we'll turn it up in a minute. So you can see the charging. It's happening right away. The battery is going to go down under load. Battery is going to charge up under charge. And of course, as soon as I turn it off, it will go back a little bit. So, I mean, I could adjust this all around a little bit. But my problem is that we're at 1 amp right now. So now I can adjust this more. So that's full speed. So you can see the double pulsing at the lower RPMs. So once we get up to higher voltage, it's going to go faster. So let's look at some of the RPMs here. So we're at 3200 RPM. $32.50. So that's with these lights on. We're at, now my meter's turned off. Time's out for me. Let's do this again. So we're at 132 amps, 1209 volts. We've got some good lighting here. And like I said, 30. Oh, that is not the, that's the temperature sensor. 3260 around. And we should look at the temperature. 76. Room temperature 74. So now I positioned these really in the wrong spot. So I want really the generator coil over top of the hull. In this case, it's the way I did the bottom one, so I did the top one the same way. Anyway, they're all cool. It's all running very cold. So let's turn it down. And then what we'll do is again turn it off. And what we're going to do is move over to 24 volts. And then move this one over as well. 24 volts. It's always difficult to get the voltmeters in there just right. Alright, so again we're going to connect this one little wire up just to 12 volts, not 24 volts. And I think the second battery wasn't as good as the other ones. or as charged. So let's get started again. Oops. So again, we are turned it down. So let's make sure we're all good here. So what we have it set up for is a good long pulse to start, and then it goes into its regular frequency. And that's how we've set it up so far. There's going to be more features over time. So again, let's go 1.8. And these aren't quite connecting there. So let's look at the temperatures. 78 Fahrenheit, we're talking about, not Celsius. Nice and cold. $37.50 so far, getting up to speed. Of course, we're still running more of a load on these bulbs, on these lights. Charging the batteries, pretty good. This voltage drop is really high on this battery. It's discharged. I should have put another battery in there. So 1.5 amps on the ammeter, 20 volts. Oh, keep doing the wrong one. So now we're at 4,000 RPM. $39.74 around. So we're going to turn it down a little bit, not as much as I had it. And then we will do this again. So we'll go up to 36 volts now. Feel this one wire is getting nice and warm because it's not really meant for that kind of amperage. Alright, so we're going to go up, and then I'm going to add the battery in a minute to see where we're at. So let's start it up again. Sure all our wires aren't getting too hot. And 0.85 amps right now coming down. Remember, this is under load, so we can load it down a lot more. I can get this all, I don't know if this is blinding the camera or not, but it's just the way it is. So we're at 2 amps right now and climbing, or descending, climbing RPM at least. Now it's starting to really take off. Oh, look at this wire here. It's good. A little bit of vibration here because it's going really fast. So I want to make sure these, last time remember we lost the fet. So I want to make sure that doesn't happen again. So now we're at 6,000 RPM almost, getting up there. Now we've had this thing up to over 10,000 or 12,000 RPM at like 77 volts input with the bigger transformer or the bigger MOSFET. So we're at 6,200. 6,222. About 6,250. It's tapping off at. Let's look at the temperatures. We're all good. You can hear it hit that resonant point again. Now they're 80 degrees Fahrenheit. It's still only 76 in here. We're very good. 81 the coils. So we're all good there. Let's look at the voltage, 31.8, charging 42.9, and it's 1.68 amps. So let's look at the spike a little bit. You can see it's a nice clean H wave, you know. And we're at 1 microsecond divisions here between each pulse. So let's go up to 48 volts now. Alright, so I wanted to get that down. So again, let's make sure that whole scenario doesn't happen again where we blow out. Alright, part of the problem was my Hall switch is right over top of the rods, and because it's the motor coil, as we're producing more power, there's a lot more field, a lot more power coming off of the coil, which is influencing the Hall. It should be a generator coil there for that reason, and that's my problem. The other problem was this wire wasn't strong enough to hold the power, so I used a different wire here. So we'll start at 36 volts again and go back up to the 48 volts. So we're going to be on the charging of 36 or 48 volts already, and it will still be able to do that. Now I've also put heat sinks on this right now because it was getting a little warm when I went to 48 volts, and I just don't want to have another incident. So you could just, as long as you have some kind of heat sink on there, make a big difference. Alright, so let's look at all these things again. I have it turned down slightly, and I should have a switch here, make it a lot easier. So we're at 2 amps. Oh. We're at 32 volts right now because this one battery is low, and mounted. Gotta turn it to 10 times probe. So now we're going to have a problem with the heat. 77. We're all good there. Let's move it up. 1.46 amps. Let's go up higher. So we're all good here temperature-wise. .58 amps, 32 volts, 56 on the charging side. So let's take it down a little bit and then we'll go up to 48 volts. In this case, I've already moved it up. So let's try this again. Two amps, and it's going to go higher. Like I said, the hull needs to be placed in front of the generator coil, not in front of the motor coil. Now we're going to go above 7,000 RPM. This is really kicking out. .7 amps is going down. 43 volts and 59 7,000 71 7,000 8,000 7,000, about 7,200 RPM. Still climbing. This thing is starting to vibrate. Alright, so now what we're going to do is remove, well, we can look at the lighting to see. So we're at 1.68 at 43 volts. We're pretty bright here. And so what we're going to do now is run the motor, or charge the battery. Disconnect these, it's going to go even faster. So I think what I'll do we're still going to leave one connected. We're going to charge this battery right here. So I can place it where you can see it. So this battery, or this, so I'm going to hook this up now. So now we're charging. Now that's under charge. You can see that. 1226. So we're going to leave that on there a little bit. 1227. Actually, let's work with this battery, a lithium battery, so you can get a better idea. So there are two parallel sets of three. It's about 10 volts on these batteries. So let's let's do that. You can see it's charging up this battery. When I disconnect it, let's just disconnect it from the source. So you can see it's coming back down, of course. So we'll move this out of the way. So now let's look at this battery right here. Sure, we get the right terminals on here. So we're at 9.9695 volts. So what we're going to do, and I just want to show all this so that you can realize this can charge batteries really well. And this is only one of the levels. So we can see now it's going up in charge. Almost at 10 volts, it's going up a little bit. You gotta hold the wire on there. So again, if I short it out, it's going to speed up the motor. Well, it's going so fast that you won't even notice it. Anyway, it's charging up that battery, and we can actually add this one if we wanted to. Let's get some more wires here. Now you can see both of them are on there and charging up this battery bank. Nicely. So it's going up. Now we still have a lot of RPM on this. Which we're not using right now. 7,924. 7,975. So 8,000 RPM while we're charging this battery. It's pretty good. So let's turn it off. You can see all the voltages now. Now this battery on this voltmeter is starting to indicate, so once a battery symbol comes on especially on a cheap voltmeter, it's not a cheap one, not too cheap, then you need to change the battery, otherwise it'll give you a false reading. So I'm not trying to do that here, but I want to show you the voltages. I'll switch around the voltmeter. This one is actually calibrated much lower than these ones. But it doesn't matter because it's relative to itself when it's testing. So you can see the voltages are going to come down, that have been charging slightly, and then the other one's going to rise up. So that's it. It does work. The heat is not bad. with the heatsink on there. Otherwise, it's just a little too much for this particular setup. Well, like I said, the hull has to be positioned correctly, and I was just doing that because I didn't want to glue it down at this point. And it should have been in front of a generator coil. So I just really didn't have the opportunity to try and hook it up there and make a big mess. I just wanted to do a simple presentation here. So again, recap. What we have here again is the new rotors. They're exactly the same, they just don't have the hub. So the set screw is through the whole body of the rotor. In this case now we can bring that closer together. I was having to file the hub down to stack it to get a decent gap. Because initially I had a much bigger gap, and then I realized it's much better to go closer. But in this case it's a little too close. But I do have a little bit shorter rods these days, so I did make that so that we could bring that rotor closer. But it's a little bit closer than I would like. It's nicer for the generator coil output to do that. So anyway, the other recap again is the new board with the ability to program it, and right now it self-starts, not with the double stack like this, but with the single stack like it normally is sold. And you can buy this double stack like this. Now I have better rods than these. These are my original rods. These are actually not stainless, so they're actually posing a bit of a drag here with the magnets. Not much, but the ones that you get will be more to the right size in the kit, and this can be cut to any size as well. I think what I'll do probably next week is do a 4 stack. I'm just gotta see if I have long enough shaft there. I think I know I can do a 3-layer, but I don't think I've got the long enough one to do a 4 stack at this point. I have to order more of those. But anyway, it's no different. Once you see the double stack, it's not going to be any different doing the 3 and 4. It'll just be more total output. You saw here we paralleled, so all the 4 coils on either layer are in series, and then they're paralleled with each other right now. Saw the lighting was definitely producing the amount of power in light that it would take to run with the power supply. 48 volts at 1 point whatever amps it was. Well, it was actually 42, so just over 100 watts, and we definitely had over 100 watts of light here, plus 8,000 RPM. And now we were actually charging this battery while we were, instead of the lights. And so we weren't loading it down as much as would be desired. So really what I need to do then is rewire these wires. Once we're getting at that high RPM, it's not loading down the system as much. So what I want to do is rewire them more in parallel. So every 2 coils will parallel up instead of every 4. And that way the voltage will drop, more amperage, less voltage. Going in the wrong direction, I know, with all this, but for people's practical application, the way it is right now, this is a very simple way of doing that. So, let's see if these are all still on. So you can see an idea, I mean, of where we're at with all this. And I can show the other voltmeter. This one's the one with the low battery, so we'll go over here. So you can see it's the same voltage still. 50.4, 50.8, that's the difference with the voltmeters. if I go over here. But like I said, once you see that battery symbol, change your battery. I've seen so many people say, oh wow, I really got some good results, and then they realize it's their voltmeter. So you can see 48.7, 48.8, 48.2. So they're not quite calibrated exactly the same either, but what we're looking at is it relative to its starting voltages. I could actually get this thing. So there you have it. So yeah, we started on these batteries here at 10 or at 9.96, 95, 96, and then we went up to 10.01 in a short period of time. And then of course this battery, which was sitting really low, it was 10.5 something or whatever it was. Now it's sitting at 11. Now these are not, this is not, I wasn't trying to like prove some great amount of efficiency out of this right in this video. Again, this is merely to introduce what we're doing here in the features. Somebody was writing a comment on the last video and they were like, what's the numbers and all this stuff, and that is something we've gone over in the past. Now it's there's much improvement with the faster MOSFET and the faster gate driver, and we can actually get better results as we tune the frequency on the generator output. And that's something that we'll get into more in the future, showing that. That's why I've left that potentiometer in there so you can adjust that. So we can still have the same charging rates and make that frequency just tuned a little bit, and all of a sudden, like, the good thing about these lights, this is one reason why I use them, is because it can show you the output of the generator coil very easily. When the lights light up brighter at a certain frequency, then you know you've hit more of a sweet spot. So there are really sweet spots in this whole thing, this whole setup here, just like there was with the trigger coil. But the good part is this is not as unstable as the trigger coil. And with the programming, we can add all sorts of features into it, and we could actually track the output, and eventually, we don't have that right now, but we could fairly easily do that, track the output, and as we see the gain, regulate the motor to the highest output. And that would be nice. And then of course have all the other features. If it loads down to a stall, we go into a mode that either stops it or turns it down. If there's no RPM after it's started, we can have the system shut off because if it's loaded down too much. So lots of features that we can do here, and like I said, the way it was running, we could have put quite a bit more load down, and that's a matter again of matching the loads, what kind of generator coils, like what kind of series and parallel arrangements we arrange them for what kind of load. These require about 36, well, start coming on around 25 volts under load, and then it's about 33 volts. These are for their maximum, otherwise they'll be, like I said, you really should only run these LEDs 75%. It's the most efficient way to run them. Otherwise you're creating a lot of heat, throwing wasting a lot of energy and a lot of time on the bulb itself. So there we have it. Again, if I had all the batteries charged up, we would have been a lot faster because I was only running, one of the batteries is really low. So it was only at like 42 volts instead of 52. And so these are all the same generator coils and motor coils. And I think we could go down a bit from 23 gauge, probably as low as 20 gauge. I tried 18 and it's just not really suitable. But I think we could go down at least 21 gauge wire here, at least for the generator coils. If we're going to run it, I think what it is if you run the generator, if you run the motor at 12 volts, it's different, completely different than at 48 volts. So you're better off setting, making the coils for the particular voltage you're going to run it at. And so there'll be a lot of variation to this kit. I don't have any 20 gauge wire right now to make that as an option, but we can do that in the near future. So thanks for watching.